Hello everyone and welcome back to another video where we'll be discussing trig identities as seen in front of you. So in my previous videos, I showed examples on how to solve and verify different equations. However, in this video, not only will we be going over different examples on how to solve and verify various trig identities, I will also be providing a brief explanation about the fundamental trig identities and Pythagorean trig identities that are very essential in learning this unit. So the first part we'll be going over are the fundamental trig identities. So in other words, these identities are very, very important to remember. So the first one we have is cosecant x is equal to 1 over sine x. The second one we have is secant x is equal to 1 over cosine x. And the third one we have is cotangent x is equal to 1 over tan x. However, we know that tan x is the same as sine x over cosine x. Therefore, if we see cotangent x and we need to turn it into terms of cosine and sine, we know that we can take the reciprocal of tan x, which would be cosine x over sine x, since cotangent x is equal to 1 over tan x. Also, a trick or something that students often get mixed up on is the fact that cosecant x is equal to 1 over sine x and not 1 over cosine x. So even though cosecant x starts with a c, its reciprocal or its opposite is going to be sine x and not cosine x. So you're going to have to find the opposite. So even though secant x starts with an s, its opposite is going to be 1 over cosine x. So just think of the opposite when looking or when remembering these trig identities. So those are the fundamental trig identities. On the other hand, we also have the Pythagorean trig identities. So these are more so equations that you manipulate when solving or verifying various problems. So the first one we have is sine squared x plus cosine squared x is equal to 1. So we've looked at this top equation multiple times as seen in my last two videos where we went ahead and manipulated this equation. When we see cosine squared x, we're able to turn it into 1 minus sine squared x, or we're able to do sine squared x is equal to 1 minus cosine squared x by subtracting either variable from various sides of the equal sign. So the next two Pythagorean trig identities to remember or keep in mind is tan squared x plus 1, which is equal to secant squared x. And the last one is 1 plus cotangent squared x is equal to cosecant squared x. So these trig identities are very important to remember, and so we will be applying these trig identities in today's video as well. So the first problem we're going to solve is going to be secant x, excuse me. So the first problem we're going to be solving is secant x over cosecant x. So we will be applying those trig identities that we just discussed. So if we're looking at the fundamental trig identities, we know that secant x, as seen in the second listed one up here, we know that secant x is equal to 1 over cosine x. So that is the numerator. We are now turning secant x and cosecant x into terms of sine and cosine so that it is easier to solve. So now we just went ahead and solved secant x, and we turned it into 1 over cosine x, as we've known from the fundamental trig identities we just previously went over. So in the denominator, we have cosecant x, which we know is the same as 1 over sine x. So now that we've changed both secant x and cosecant x into terms of sine and cosine, we are able to go ahead and take the reciprocal of 1 over sine x so that we're able to no longer have a denominator. So we're going to go ahead and do 1 over cosine x times, and we're going to take the reciprocal of the denominator, which is sine x over 1. So now that we have that, we're just going to go ahead and multiply across. So we know that 1 times sine x is just going to be sine x over cosine times 1 is just going to be cosine x. So sine x over cosine x is one of our fundamental trig identities, which we know is tan x. And just to reiterate, if it was, let's say, cosine x over sine x that we got in the end, it would be cotangent x, as seen in the fundamental trig identities we discussed at the beginning of the video. We know that sine x equals cosine x is equal to tan x. So we will now be going over another problem where we can be seen applying our fundamental and Pythagorean trig identities. So this is problem number 2. So this problem is going to be sine x, or any other variable, doesn't really matter, plus cotangent x times cosine x. So this problem is a little harder. However, I will be going over step by step on how to solve this problem, so stick along. So the first thing we're going to go ahead and do is turn this entire equation into terms of sine and cosine, as we've done in the previous equations as well. So we know it's sine x plus, and we know that cotangent is the same as cosine x over sine x. Because remember, cotangent x is the opposite of tan, which is sine over cosine. So cotangent is cosine over sine. So then we're just going to multiply that by cosine x over 1. So now that we've turned this top equation into terms of cosine and sine, we can go ahead and continue solving. So we know that we have sine x plus, and if we multiply across, we get cosine squared x. Oh, sorry, that's supposed to be a 2. Over sine x. So now that we have two different sides, we have to, since sine x is over 1, we have to change, or we have two different denominators. Therefore, in order to make it 1, we have to make sure that both fractions have this common denominator. So in order to do that, we have to multiply the left side by sine x over sine x. Like so. So we would get sine squared x, because sine x times sine x is sine squared x, over sine x, plus cosine squared x over sine x. So now that they have the same denominator, we can treat this as essentially one fraction. So we can just go like this, and it would essentially just be one fraction like that. So if we're disregarding this other sine x on the other side, it would really be sine squared x plus cosine squared x on the numerator, and on the denominator, we would have just sine x because we turned it into common denominators. So sine squared x plus cosine squared x is actually one of our Pythagorean identities, which is sine squared x plus cosine squared x is equal to 1. So we just change that numerator into 1. And then it would be 1 over sine x. And if we're looking back at our fundamental trig identities, we know that 1 over sine x is the same as cosecant x, which would be our final answer. And that is how you simplify that equation. So in this video, we went over the fundamental trig identities as well as the Pythagorean trig identities, and we were able to apply both of those into two various problems. And so I hope you guys learned how to apply both fundamental trig identities and Pythagorean trig identities and how to solve various equations.